So are you guys able to see the screen?
Yes, sir.
Yes, we are.
So today we are going to cover VPN. Okay. So can anybody tell me what is a VPN? Like what is a VPN and what is the practical use of a VPN in an organization?
Well, it extend the network from a private network to a public network, and so that the users from other location can connect to that private network.
Correct. So we will cover, and today's session will cover introduction of VPN. We will mainly there are two types of VPN that are used. That is site-to-site VPN and remote access VPN. It depends on how we are going to we classify the VPN. Okay, so if we classify the VPNs can be classified in many ways actually. Okay, it can be classified based on OSI layers, for example L1. Okay, L1 overlay VPN, T1, if you have heard T1, E1 links, right? Those are also like a VPN, L1 VPN actually. Okay. Then we had frame relay, ATM, that those were L2 overlay. Then we have L2 and a half MPLS, right? It is also provided by the service provider. That is also an overlay. Apart from that, we have L3 overlay VPN, that is IPsec GRE tunnels. And then we have SSL VPN that is mostly used for remote access VPN, and that is L4 only. So we can classify it based on OSI layers, based on how we are configuring it. For practical purpose, we'll just cover like mainly there are site-to-site VPN and remote access VPN. That is what we are going to cover in today. 1 second. So this is just a definition of VPN actually. VPN is basically used to connect two private network across a untrusted network or a public network, right? As Alisa was mentioning. Okay, so why do we, the main purpose of using VPN is to save cost, right? So we can use internet uh, as our underlay transport and configure an overlay tunnel between two different sites. We can encrypt that tunnel, right? So that we can save the cost on MPLS and dedicated links. Is that part clear?
Clear, boss.
Yeah. So main thing is it should provide the connectivity between two sites as well as it should provide security, and we should be able to manage it. Like ease of management also is one of the aspect. Okay. Let's go to the next slide. Okay, so mainly types of VPN, as I said, right? Site-to-site VPN is to connect between two different sites from a head office to the branch office, right? Many banks actually, many banks have site-to-site VPN actually. Apart from that, like towards its branches, right? They might, if the branch is in a very remote location also, they will be having a very secure connection. It might be that VPN is used as a secondary mode if they have MPLS, dedicated MPLS providers that at that remote location. But if there is no MPLS providers, or if there is a cost constraint, they will go for VPN. Okay, so many companies are not only from bank perspective. Many companies are using site-to-site VPN to connect to their remote branches. Okay, Apart from that, if we are connecting, like a home user is connecting to office, okay, they can use remote access VPN or SSL VPN. Okay, so basically the user is connecting to the site via a untrusted or internet transport, and all the security measures are complied with. Okay, so it is a secure tunnel that it is being established from the endpoint to the site, to the VPN gateway. Okay, so is this part clear? Remote access VPN and site-to-site VPN.
Yes.
It's clear.
Yes.
Yes.
So benefits, we have already covered this in one of the earlier sessions also. So benefits of a VPN like is security, reliability, scalability, network management. We can push all the policies to all the VPN in a single management plane, right? So those are all the well-designed VPN features. Okay, so we want to, if we want to have, like if we have a VPN, it should be secure. Okay, and if it should be reliable in the sense the internet connect, like internet, the VPN gateway should be stable. Okay, and the connectivity to the users should be stable so that they can work from home or they can work remotely. It should be scalable, like it should be, if they want, like if we in practical purposes, we have seen that more than 16,000 to 20,000 users can work right on remote access VPN. So it should be scalable if required. We should be able to scale it with the number of users, or if there is a heavy traffic required for the home users, that it should be able to support it. Okay, and any doubt in this part actually? Security, reliability, scalability, network management, policy management. This part is clear?
Yes, boss.
Yes.
Yes.
So we are mainly going to cover IPsec VPN. Okay, so IPsec VPN is basically, IPsec is a protocol stack. Okay, IPsec provides the three things that that is required for security. That is confidentiality, integrity, and authentication, as well as anti-relay. So when we say confidentiality, can anybody tell me what is confidentiality? What do you mean by confidentiality? Alex?
It's like the privacy of a network practically, that anybody can access something if they are authorized to access it, or basically the level of privacy that will happen up to on that certain network.
Okay. Alisa or Vivian, what is encryption?
Sorry, encryption. What do you
Correct.
mean it is securing or encrypting the files or the datas within the organization. It's like putting some password, just like that.
Correct. So it is like will put something like cipher. Yeah, we will mix the data, right? So that once it is reaching, like earlier days in war on, also we will encrypt our data so that if the enemy is getting our message also, they will not be able to decrypt it. So we will, there are many ciphers, encryption ciphers that are available for encrypting the data, right? So that is the first thing, encryption, confidentiality. And what do we achieve with encryption? Confidentiality is what we achieve with encryption. Okay, so if we want to send the data confidentially to somebody else, we will encrypt the data. Okay. Next one is integrity. Integrity is if we are sending a data to from one side to another side. Okay, and if somebody is capturing the data and modifying it, actually, they it should, like like we should come to know that the data has been what do you say, compromised. Okay, so how will we come to know? So basically we will use some hashing algorithms. Okay, so once the data is being, when the data is being pushed, the hashing algorithm will generate a hash and it will send it with the data. So once the data is reaching the end like endpoint or the destination, right, it will again check for the hash, right, for the integrity check. And if the integrity check and data matches, then the data is safe. Actually, it is the data that was sent. Okay, so that is how it checks. So we use hashing for integrity. Any doubts in integrity part for hashing?
None, boss. None.
And then we have data authentication. For authenticating between two sites, we'll just use a authenticator permission. We can either use a certificate, or there are multiple ways, right? We can use certificate. We can use a pre-shared key for authentication. Okay, if it is remote access VPN, we have multi-factor authentication also to ensure that the user is the user whom we want to provide the access. So we might have send a SMS to the users, users endpoint or users mobile, so that only the user can provide that code actually. Okay, so that is what we call as authentication. Authentication, mainly for authentication, we use pre-shared key or certificate. Okay, and then we have anti-relay. Anti-relay is if suppose for some reason the data is captured and it is compromised. If the hacker knows the encryption algorithm, okay, and he knows how to modify the data without compromising the hashing also. Okay, it is very hard to do, but if it is possible also, it will take a lot of time. Okay, so we'll give a some timeout period actually. Okay, so within that, if the data is not being received within that time period, okay, we can say that the data has been compromised. Okay, so that is what we use anti-relay also. Okay, these four parts are clear.
All clear,
Very
boss.
clear.
Okay. The main protocols that are used in IPsec protocol, like Ipsec Vpn or Ipsec protocols, are IK, Internet Key Exchange, and then we have encryption. In the phase 2, we use ESP and AH. Okay, so Ipsec VPN itself, we have two phases. Okay, phase 1 and phase 2. So what happens in phase 1 is, in phase 1, it negotiates the parameters, like the parameters for the confidentiality, integrity, basically the security parameters that both the VPN peers can agree actually. Okay, so they can for encryption they will agree on a encryption algorithm. For hashing they might agree on SHA or MD5, right? So what algorithm or what security parameters are we going to use? So that is being negotiated in the phase 1. Okay, so during the phase 1, one tunnel is built, and that is a bidirectional tunnel. Okay, that is a bidirectional tunnel that is built in the phase 1. Okay, and in that phase, it will authenticate. It will it will exchange the security parameters, and once it agrees, then only the first phase or phase 1 tunnel will be formed. Okay, for that we use IKE mainly for internet key exchange. Okay, is this part clear?
It is clear.
Okay, so Sheila, any doubts still in this one? Okay, so if you see here, in the phase 1, we use UDP port 500. So whenever you see whenever VPN, when a VPN is trying to establish site-to-site VPN or say remote access VPN also, at that time it will try to negotiate the security parameters. So at that time it will be using UDP 500 by default. Okay, and once the once the security parameter has been agreed upon between the two VPN peers, okay, the bidirectional tunnel will be formed. Okay, so when it is exchanging this security parameters, okay, for confidentiality it might use AES or DES. Okay, many algorithms are there. Okay, so for integrity it might use SHA-1 or MD5. For anti-relay we set a timeout actually, right? And then one more thing is Diffie-Hellman. Okay, so you might have Diffie-Hellman. Diffie-Hellman is basically used for for exchanging the key. Authentic pre-shared key is there, right? So if you, the key between the two VPN peers, how it is exchanged? It is also exchanged securely using Diffie-Hellman algorithm. Okay, so it is not just given directly. It is exchanged using Diffie-Hellman algorithm. So that is where Diffie-Hellman comes into play. So we will be using Diffie-Hellman itself. He has many groups actually. So how much you want to what do you say, secure the key? Okay, so if we nowadays we have group 15, group 14 also. We can use group from group 2 also. We can use say group 2, group 5 for lab. Okay, but in production we might try to use group whichever is the latest group that is there. Okay, depending upon our security requirement, as well as we will have a standard. Okay, or the client will define a standard and we will apply the same parameters for on our side. Okay, so till this first part that is clear. First part, negotiate the parameters.
Yes.
Additional. A single,
Yes,
it is a
boss.
single IKE bidirectional tunnel. Okay, single key is used for authentication. This part is clear.
Yes, boss. Clear.
So it negotiates a proposal. Okay, and sometimes it will say the proposal is not matching, right? So that is all phase one. It will show us phase one proposal is not matching. Okay, so it is not agreeing on these three parameters or this couple of parameters. It is not agreeing actually. Okay, so confidentiality, integrity, authentication, or Diffie-Hellman group or timeout. Right? So we will have to check it out. What is setting out. Next is when these messages are exchanged, there are two modes for exchanging the method, like two modes of exchanging these what is say these security parameters. Okay, so one is main mode and another one is aggressive mode. Okay, so we use main mode for almost all the VPN. Like if we have site-to-site VPN, DM VPN, right, dynamic multi-point VPN, get VPN, all the VPNs we use main mode. Mainly the aggressive mode is used in remote access VPN. Okay, so what is the main difference between main mode and aggressive mode? Is just the number of packets that is being exchanged. Okay, so in main mode we exchange 6 packets between the VPN peers. If we have when I say VPN peer or VPN gateway, you can understand the basically the VPN is being formed between two firewalls or one router and a firewall, right? So that is called a VPN gateway or VPN peer. Is that part clear? When I say VPN peer, you're able to understand, right? What is a VPN peer or VPN gateway? Okay. So
Yes,
when
boss.
the message is being exchanged for forming the bidirectional tunnel, phase one bidirectional tunnel, right? So in main mode, it will exchange 6 packets, 6 message. Okay. Whereas in aggressive mode, it will exchange only 3 packets. 3 message. Okay, so what is the 6 message that is being exchanged in main mode? So what happens is, first of all, the initiator will send the response, like send the proposal actually to the responder. It will send all the parameters, that security parameters are there, right? Okay, it will send it to the other end actually. The next, like the VPN peer. Okay, now VPN peer will send its proposal to the initiator. It will send the next, like say we are forming a VPN peer between site A and site B. So site A VPN gateway will first send, if it is the initiating. Okay, so if it is initiating the tunnel or VPN, it will send the proposal to site B VPN gateway. Now site B VPN gateway will send the proposal to site A VPN gateway. Okay, next in main mode, what happens? It will what we say is the third message is it will send the key using the Diffie-Hellman protocol, right? And again, the responder, the site B VPN gateway will send its key using the Diffie-Hellman protocol. Okay, now the initiator first will authenticate the session. Okay, yeah, this is matching, so we can start, right? The responder will again authenticate. So once this 6th step is done, then only the tunnel will form. Okay, is this part clear?
It is clear.
Okay, so there is a one good link that I had. 1 second. I put it for you somewhere. So you can use this one actually. It will, like, suppose we are stuck in some phase actually, like in some message we are getting stuck. Okay, we can troubleshoot what is that particular message. Okay, so for that we can use this particular link. But for the basic purpose, okay, not just we have to first of all configure it, but for the theory purpose, is this part clear? Main mode is clear.
Yes.
Okay. So for in aggressive mode, what happens is it will, when the initiator is initially sending the proposal, it will send the key also. Okay, and then the responder will also send the key. What do you say? It will send the key as well as it will send its own proposal. Before that, it will authenticate the initiator. Okay, and finally, the initiator will authenticate the responder. So this is how it happens in aggressive mode. Okay, so aggressive mode is mainly used in remote access VPN. The main mode is used in site-to-site VPN. So definitely this is a very important thing that you should always understand. Okay, so main mode is always where is main mode used? Main mode is, what is main mode? How many messages are there in main mode, right? And by default in site-to-site VPN, which is the mode that we are using in phase 1? Main mode. Okay, and which is the mode that we are using in what do you say, negotiating and forming the tunnel in remote access VPN?
Aggressive.
Aggressive mode. Okay.
Aggressive.
Correct. So this part is very important in the theory part. If you have to understand it, and whenever you're using it, right, by default it is main mode in site-to-site VPN. Okay, so this part is clear for you guys?
Yes, boss.
Okay, great. Next is in phase 2. Okay, so phase 2 is basically for once the once the security parameters are exchanged, it is agreed upon. Next, the tunnel is being built for transferring the traffic. Okay, so in phase 2, the tunnel is for transferring the traffic. Okay, so data transmission, right? The traffic in the tunnel is formed. So here in phase 2, there will be two tunnels, one for transmit and one for receive. Okay, so there will be two tunnels that will be there. Inside that tunnel only the traffic will be sent actually. And this tunnel itself is again encrypted. Okay, so we will be using ESP or AH for what we say, again forming this tunnel actually. So it is very secure actually, and we are saying, right, VPNs are very secure. So in phase 1, first of all, the security parameters are exchanged. Okay, in phase 2, where the data is being sent actually, that is also, there will be two tunnels, one for sending and one for receiving. And again, this tunnel is being formed using AH or ESP. Okay, so authentication header or encapsulation. Okay, so we can we can go through what is ESP and what is AH actually. Okay, so mainly for VPN actually, nowadays we don't use AH anywhere. Okay, it is obsolete. We are using only ESP. Okay, before going into details on that, did you understand the basics? What is phase 2 in IPsec tunnel?
Yes.
Okay, yeah. So this is an interactive session. If you have any queries, right, just inform, or also I would like if at least if you can say that you understood, right? It will be, we can move it very little bit faster. So hopefully you have understood this portion. Now we'll go to ESP and AH. Okay, so ESP and AH, as I said, it is authentication header. It is also used for encapsulating the data, right? But it does not encapsulate the header itself. Okay, I have one. Let me check. Yeah, so in AH actually, authentication header, it does it. What do you say? It does not have, it does not encrypt actually. Okay, it does just it does the encapsulation, but it does not encrypt the data. Okay, it does not include the external IP in the ICV, in the what you say, in the encryption, right? It does not use the external IP address. So what do you mean by external IP and internal IP? So whenever whenever the VPN tunnel is being formed, right, the data will be using a different IP address, right? Suppose we have say. Okay, so we have this is our VPN peer and this is another VPN peer. Okay, and this will be having IP address say 100.100.100.100, and this is having IP address 200.200.200.200. Okay, now this is the external IP address. Okay, now what is the what do you say, IP address that is communicating over this tunnel? Okay. Over this tunnel, the IP address that is communicating is the LAN IP address 192.168.1.0/24. And say here we can say 10.10.10.0/24. Okay, so this is the source and destination basically will be this one. Okay, from any IP in this one, but it will be encapsulated with the external IP address, right? Okay, so when we say external IP, it is the IP address of the gateway. Is this part clear?
Yes, boss.
Yeah, so it does not include the external IP address in the when it is doing the encapsulation. That is what it is saying here. Okay, when we are using AH. Okay, and it does not support NAT. Okay, so that is the reason AH is not used much because encryption is not there. Okay, and secondly, we don't have NAT support. Okay, is this part clear?
So the traffic can go directly since there is no nothing, boss. I mean,
Yeah. Traffic will go directly if there is no natting. That is a valid question actually. So let me come here again. Okay. So if we have this one, right? So what will happen is okay. So here the external IP will be like source IP will be basically 100.100.100.100, right? And destination IP will be okay 200.200.200.200. Okay, and we are using AH, right? So AH will be the tunneling, but it is not encapsulating the what we say the external IP address. Okay, so here the source IP, original source IP will be from the internal IP address, say 192.168.1.100 is trying to communicate to DIP 10.10.10.101. Okay, so suppose this is a packet that we have. Okay, so when it is creating, when it is like encapsulating, right, it will only use the what we say, it will use the all the parameters, PSK, as well as it will use the source IP address. This one, source IP address and destination. It will not use the external IP address. Okay. So why we say that NAT is not being supported, right? Okay. I will tell you. That is a very good question. That is a very valid question also. Okay. I will inform you. Okay. So then this part is clear for at least
Yes.
part. Okay. So once we come to the ESP, what happens is same thing. The destination, what do you say? The source IP address is same. Destination IP address is same. But what it does is slide. The external IP is not encrypted. Okay, so external IP is not encrypted in ESP. Okay, external IP address is not encrypted in the ESP part. Okay, and it supports the NAT. Okay, and so what happens here is, let me come here. If we prepare like so suppose we are just preparing an ICV. Okay, ICV, you can say it is the encrypted thing. Okay, so if you're preparing an ICV in AH, what will happen? It will use what all things it will use. It will use the PSK security parameters. It will use the original IP address, original IP had like payload, right? And it will use the external also. Okay. Whereas in what we say in ESP, it will use only the internal IP address. Okay, it will not use the PSK, and it is not using the external IP addresses. Okay, so what is happening here is, suppose this VPN gateway. Okay, VPN gateway is behind the public IP address. So many cases what happens is the VPN gateway might not be having public IP. So it might be an IP address that is a internal IP address, say 192, some other IP address, say 192.168 2.10. Okay, so we have a what we say, we have a VPN gateway with a private IP address, and we want to like form a VPN tunnel with another VPN peer which is having public IP address. So what should happen here? When the traffic is going out, it will be NATed to the public IP, right, from the site A. Do you agree?
Yes.
Do you agree? Yeah. So in that case, what happens? With AH, it does not support NAT. Okay, so it will not be able to form a VPN tunnel. Okay, whereas with ESP, it supports the NAT and the external IP address is not encrypted. So external IP address still, it is when it is going from one side to another side, the external IP address is not getting encrypted. So what happens? It can support NAT, and what we say, the VPN tunnel can be formed actually. So that is where the NAT will come into play. This is not the NAT that we are talking about for the traffic to go outside, like for internet. This is the NAT when we are forming VPN tunnels between VPN peer. Okay, suppose the VPN peer is behind a public IP. Okay, at that time, NAT is required. Okay, so at that time, when we are when NAT is required between between the VPN peers to form a VPN tunnel, right? So we need a protocol, encapsulation protocol that supports NAT, and ESP is the protocol that will support NAT. Okay, this part is clear.
Okay. Yes.
So how it does is, that is also one more point. How it does is basically, what it does here is it will just, and when it is ESP, right? What it does is, so when it is ESP, right? So what it does is it will add one more header to it, that is NAT. Okay, so you might have heard when you're when you're doing VPN configuration, you might have a NAT tree or NAT traversal. Okay, so it will add one more header to it actually, NAT T. It is a UDP 4500. Okay. What it will do is it will add a NAT T header in the in the payload actually. So we will come to know that what we say the packet is natted. Okay, so NAT itself is only supported in ESP. So what will happen is first of all the packet is being sent to the destination. Now once the destination has got the packet, right, it will first of all check for the NAT header. Okay, so it will check for the NAT header actually. If NAT header is there, then it will it will take a decision to add port 500, 4500. Okay, so that is how sometimes the client will say that NAT has to be supported. Okay, if the VPN gateway is behind a public IP, it does not, the VPN gateway does not have a direct public IP address. At that time, NAT needs to be supported. Tell me one practical case where this is required.
For
Or remote access.
real.
Yeah. So when we are doing remote access VPN, right, you are basically using a public IP address.
Yeah.
Or you are using a private IP address, right? It can be anything. Okay. So that is for remote access VPN, but the NAT purpose is clear for you guys. Okay.
Yeah. The difference, the one that you mentioned is more clear.
Okay. So basically, in the phase 2, we use either authentication header or ESP for encapsulation. Okay. Mostly ESP is used. Okay, because it supports encryption as well as it supports NAT. Okay, so that is the reason it is what you say NAT ESP is more preferred, and it is the protocol that we use for phase 2 actually. Okay.
Okay.
This sentence is little bit no, yeah, it is mentioning external IPs included in ICV in AH. Okay, external IP is included in AH. Okay, whereas external IP is not included in ESP. So what happens whenever we need to have a packet again same coming to here actually. So if the external IP is included in the encapsulation, then when the packet is being sent, okay, suppose we are doing a NAT like PAT, what happens? We need a IP address and we need a port. Right? Whenever we are doing a PAT to a public IP, we require first of all we require a public IP address, and then we are using PAT, right? We will do a port address translation. We will add a port number to it, right? To each connection. So here also in AH it is not possible. In ESP we have the public IP address. It is not getting encapsulated, so we have the public IP address to which the NAT header has to be added. NAT header, if NAT header is 4500. Okay, and then it is getting the NAT is happening actually with 4500. Okay, so if you are seeing NAT basic, if you are seeing port like traffic with 4500, you should understand that it is the other end IP address is behind a public IP. It is a private IP address. Okay, this part is clear.
Yes.
NAT itself
Yes,
is
clear.
like we have a couple of like steps in NAT, as I said, right? NAT support, NAT detection, decision rules, but we are not going in that much detail actually. From the basic perspective, did you understand the difference between ESP and AH?
Yes, boss.
Okay. What about Sheila, Vivian? Sheila, Vivian? Okay, Sheila is Vivian. You're still there? Okay. Your voice is not audible actually. Alex, this part is clear to you?
Yes, Santosh, it is clear, yeah.
Okay. Next is the IPsec mode actually. So IPsec mode itself, we have two modes actually. One is transport mode and tunnel mode. Okay, so when we say when this data is being like encapsulated, right? After that, the entire packet, right? Entire packet is if it is tunnel mode, what is happening? The entire packet is getting new header. Okay, so entire packet will be getting a new header in tunnel mode. Okay, whereas in transport mode, the original header will be there. Okay, it will add what do you say? It will add a encrypt the payload. Only the payload is getting encrypted. Only the payload is getting encrypted. Okay, so whereas in transport mode, the encrypts the payload as well as the IP header, and we will have a new IP header. The IP header is not getting encrypted in transport. Okay, so we will get this type of what do you say? Where is transport mode used, and which like mainly which is the mode that we use in site-to-site VPN. Okay, we by default we use only tunnel.
Okay.
Only tunnel mode we are using. Okay, so we will be using only tunnel mode in 1 second. There was a spelling mistake in there. This is tunnel mode. Okay, so there was a typo here. It was mentioned as transport mode. So in tunnel mode, it will encrypt both the payload and the IP header, and we will have a new IP header, the packet. Whereas in transport mode, it will only encrypt the payload. The original IP header will still be there. Okay, so this is the basic difference in what do you say, transport mode and tunnel mode. In all the VPNs, RA VPN or site-to-site VPN also, we are using tunnel mode as our what do you say, by default. Okay, there is no, we don't have to do much configuration on tunnel mode actually. But from the theory perspective, we should know that there are two IPsec mode. One is transport mode and tunnel mode. In transport mode, only the payload is getting encrypted. Okay, whereas the IP header will not change. Okay, so this part is clear.
Yes, boss.
Okay, Alex.
Understood, yeah.
So this is the basics for site-to-site VPN. Okay, now we can go to remote access. So remote access VPN, we have three modes. Okay, like mainly when we say remote access VPN, right, it is SSL VPN that we are using. Okay, from the Cisco ASA perspective, in SSL VPN, we have three modes. Okay, one is clientless mode, another one is thin client mode, and thick client mode. So remote access VPN, you understood, right? What is remote access VPN?
It's accessing the network via remotely.
Remotely from an endpoint. Okay,
Yeah,
from an endpoint, from user perspective, right? So if we are using like that, then we'll mention it as remote access VPN. So if we are using SSL for that, right, it will be a SSL remote access VPN, and that is the VPN that we have nowadays when we use AnyConnect. It is a SSL VPN. When we are using Global Protect VPN in Palo Alto Firewall, it is a SSL VPN. Okay, so it is using SSL basically for securing the data. Okay, so we should understand, right? For encryption, we use SSL basically. Okay, so SSL VPN itself has three modes. In Cisco ASA Firewall, it is almost same in most of the firewalls, but from the Cisco ASA perspective, we are going to study in this session. So in there are three modes. One is clientless mode, inclined mode, and thick client. So in clientless mode, as it is clear actually from the sentence itself, right? We are going to connect to the VPN gateway via the HTTPS browser. We'll just connect. Okay. And from there, we can access some internal portals. Okay. So we can access if you want to access a HR portal or any specific portal that we need to access, right? We can access from after connecting to through the browser, we can connect to the VPN gateway, HTTPS labcompany.com. Okay. And then once we authenticate, we can access some links which are only accessible from inside the network. So this is basically used for web apps. And like the VPN gateway will be acting as just like a proxy. Okay, so when you do a packet capture on the web server, you will not be able to see the IP address of the endpoint. Okay, what IP address you will be seeing? You will be seeing the IP address of the VPN gateway. So VPN gateway will be acting as a proxy. Is this part clear?
Yes, understood.
Okay. Thin client mode is just like clientless. Only thing is it will support non-web apps. Like suppose we want to do RDP to our jump box. Okay, or SSH to we need to enable SSH to our jump box or some specific server. Okay, so we can for that also we can just log into the portal, VPN gateway portal, and from there we can provide. It will provide a Java-based application like a application from where we can just click and from there we can access the RDP, SSH, telnet. Those are all non-web apps actually. Okay, so this part is clear.
Yes.
Yes, it's clear.
Next is the thick client. In thick client mode, basically we use web like our AnyConnect. Okay, so in AnyConnect we can access anything, like we can access internal websites, we can access non-web apps, right? We can directly do RDP, we can SSH. Okay, it provides us the network layer access using AnyConnect. Okay, so this is the basics for what we say site-to-site VPN and remote access VPN. Okay, now we'll go to the practical part.
All right.
That I have prepared. So I have prepared a small lab for that. Okay. This is the same lab that we were using earlier for Palo Alto Firewall also. Okay. So here we have added a couple of ASA firewalls also. I've added router. We have Palo Alto Firewall as well. So we can just switch it on. Okay. Switch on. So if you see here, what we are going to do is we are going to form a VPN between these two ASA firewalls first. That is our first task. We are going to form a VPN tunnel between these two ASA firewalls. Okay. So what the public IP address? This is the outside arm, right? And this will be the inside. Okay. For inside, we will be using IP address 192.168.1.0. And for the next side, we will be using 192.168.150.0. Okay, and for the outside, for the first site, we'll be using 100.100.50.0/24, and another one we can use some other property. So this topology is clear for you guys?
Yeah, basically.
Mhm.
Okay. For others?
Yeah, it is.
Okay. I'll switch on the. Let's start. Windows has crashed. As it is lab, we don't have to troubleshoot on the Windows endpoint. We'll just replace it. So we are going to see both from front end as well as from GUI. Okay, from GUI as well as from CLI. Okay.
Okay.
So first is we will give the IP address. Okay. You start by giving the IP address. 192.168.150. Okay. 150.1 will be the IP address of the firewall. So we have set the IP address. Give a ping here.
Yeah.
So on the router, all the IP addresses are already configured. Ports are up. Okay, we will just have to configure it on the tab 3. And here the interface gigabit 0/0. Int gigabit 0/0. That is the outside interface. So IP address name it. What about one of you guys can guide me on giving the IP address? Alex, I think we are just doing the basic
Yeah.
IP address actually. Okay, so you are able to see the background screen, right? The lab image.
Yeah, I can see the diagram.
Okay. So what is the IP address that we have to give on the outside? You can just tell me fast.
For the outside, we need to set the IP 100, 150. Yeah.
We can give 50.1 or we can give 50.101 and in any IP address that we want. Okay. Let's take on the ISP router what is configured. It is 50.1. So we'll give 101. Okay. And then no shut, right? And then we have to give route outside default route, right? Should it point to default route should be pointed to.
Correct.
Next, we will configure the inside interface. The inside we will configure gigabit 0/1. And if then we can configure it as IP address 192.168.1.1. Oh shit. Let's see. 1.1 is pinging. It's pinging. 101. I think we did not set the IP address on the.
Yeah, I think not. Let's see.
Okay, it is 1. We can give it to 101. One second. we are able to ping the inside, right? This part is done. Site A, we are able to come here also, we should be able to ping the inside V. So this site is configured. Okay, now we can check the ISP is pinging. We can check ping.100.100.50.1. We are able to ping the ISP also. Okay, now we have to make the reachability to the other VPN peer. So it was lab. Okay. Site B. And here we have to, what is the public interface here? What is the interface that is connecting to the ISP on this firewall?
It should be 0, 0.
Give it as outside. Okay. 100.100.150. 101, right? So we'll give it as shit. We are able to ping the ISP. Are we able to ping? Are we able to ping 100? We will not be able to ping, but I wanted to show you 100 dot. We are not able to. Why we are not able to ping? It is showing clearly why it is not able to ping. Tell me, what should we do here?
We need to set a route for that.
So we need to add a default route outside. We should be able to ping. So between the VPN peers, we have the reachability. Is this part clear?
It is clear, yeah.
Yes, boss.
We have to configure the inside interface. So inside interface is gigabit 0/1. 0/1. What was the IP address is 192.168.150 dot. We can check. We are able to reach 192.168.150.1.
Correct.
So all the reachability part is done. IP addressing is done actually. Okay. So now we have to set the site-to-site VPN. So for setting the site-to-site VPN, for configuring the what we say phase 1 and phase 2, right? We can configure first for phase 1. We have to configure the crypto policy. For phase 2, we have to configure the transform set and crypto map, right? Instead of that, we can like here in ASA Firewall, we have a very good option actually. So we can just go to conft and we can type VPN setup, right? And here we can say we want to form a site-to-site VPN. What are the steps for it? So the firewall itself will show us. Okay. So see, these are the steps that you have to follow for a site-to-site VPN. Okay, first is the IP addressing. Second step is to form the phase 1 crypto policy, where we mentioned all the encryption, what is it, hashing. Okay, this is the basic steps. Okay, here we can add Diffie-Hellman group also. Okay, it is not done here, but if you want, you can add it actually. Okay, So these are basic steps that we require for forming a VPN tunnel. Okay. Once this is done, the what we say, we will be able to form phase one. Phase one, we require the IP address also, like this key also. Okay. Then in phase two, we require transform set. It is attached to a crypto map. Transform set is attached to a crypto map. In phase two, we mentioned which is the VPN peer. Okay, and the interesting traffic. Okay, this is a policy-based VPN. Okay, there are two in VPN types, right? We mentioned site-to-site VPN, remote access VPN. There is another type of VPN. Like when we do classification, we can say route-based VPN and policy-based VPN also. Okay, so when we say route-based VPN like GRE tunnels, like DMVPN, so those are all route-based VPN. The VPN tunnel in Palo Alto firewall, it is a route-based VPN. Okay, where we have to route the remote and IP address to a tunnel. Okay, so that is called route-based VPN. Whereas in here actually there is no tunnel interface in ASA firewall. Okay, so we define the interesting traffic that has to go through the VPN. Like when we say tunnel, like there is no tunnel interface, right? Am I configuring interface tunnel 0, anything like that for a VPN in ASA firewall?
I
No.
think so.
No, we are not configuring it. Okay, so that we configure policies actually. We configure the access policies and we mention what is the local IP address and what is the remote and IP address. And this is the traffic that has to be encrypted. Okay, so this we call as policy-based VPN. Okay, so this is all part of phase two. This is part of phase two. Okay, so you understood the commands. It is very simple commands actually, and it is provided on the ASA firewall itself. Okay, so we can just copy it to a notepad. Okay, so we can say then this same thing we can use actually if you want. Okay, we can either we can use your thing actually. We can say tset or anything like whatever you want to. Okay, ACL. What is the IP address that we are using? On the first site A, we are using 1. On the other side, we are using 192.168.150. Right? And tunnel group.
Correct.
Tunnel group, the second IP address was 150. So 100.100.150. Okay. So this one also you can use any one you want. Okay, and any PSK that you want, pre-shared key. Okay, you can use Cisco or anything, but it should be complex. If we we are using it with special characters, right? It will be a little bit hard to crack. So we will keep this one for lab. Okay. So we are calling the access list. We are giving the IP address of the peer for the phase 2, right? Here it is not tset, it is transform set. Reverse route, you don't require reverse route. We can add, it will add the reverse route by itself, so we don't require that. So okay, if you want, you can keep it that also. That is a additional option that we have for adding reverse route. Okay, so let's go one by one on each of these commands. So what we are saying, we are saying that we are going to use for encryption, we are going to use AES. Okay, In AES itself, we have AES 256. Okay, we are not going to be just this as this is lab. We are just keeping the same parameter. Okay, so we are going to use AES 128, right? Bit encryption. We are going to use SHA-1. Okay, if you want to add Diffie-Hellman, we need to add group say 2 or 5. Okay, so as of now we are keeping it default. Okay, so this is for the phase 1. This part is clear.
Yes, understood. Yeah.
In phase 2, we are saying the ESP. We are going to use for the phase 2 tunnel, right? We are going to use ESP. Encapsulation, for encapsulation, we are going to use ESP, and the encryption will be AES. For integrity, we are going to use SHA. This part is clear.
Understood as well.
Yes,
Okay.
boss.
And then we are going to use the same in the, we are going to create a crypto map. And in crypto map, we will call the whatever transform set we have created, right? We will call it, we'll call the access list. Okay. The data traffic that has to go through the interesting traffic, right? The VPN interesting traffic. We'll be calling it in the crypto map. We'll be giving the peer IP address. Okay. And then we'll attach that crypto map to the outside interface, as well as we will attach the ICMP policy, right, to the outside interface.
Understood.
This part is clear. Any doubts?
Yes,
Yeah.
boss. That's clear.
Okay. This is,
Yeah, basically,
fine. Yeah. So you're asking something. Your voice is not audible.
which mine?
Yeah, you are asking something.
No. I was just saying that it is all clear.
It's clear. Okay.
Yeah.
Vivian. See, as I always say, right, either like whenever there is no queries, right, it is either you have understood it very clearly or you have not understood at all. Okay.
Yeah,
So,
I have practically.
yeah. Okay. Yeah, it is clear for you. Well, Vivian, Alyssa, Sheila, is it clear for you guys?
Yes, it is.
Okay. So we'll go to the next for the next firewall, right? We can do the pre-scripting whenever we are implementing doing any changes in network. First of all, we have to prepare the script, right? And then we have to take it for review, peer review. Then we have to take it to the CAB for approval. So the script has to be there. So the same thing, we'll first of all prepare a script actually. So again, this is for from lab 4 to lab 3 firewall. So same thing, policies by same, right? Peer IP addresses. Okay. Your IP address is changing. The interesting traffic also will change, right? So it will be the source will be from, and here also the peer IP will change.
Correct.
Right? This part is clear. Okay.
Understood.
Yeah, but the IP address that we
Yeah,
give in the peer is wrong. Nobody noticed it actually.
100.
So let's copy paste it and check if everything is good.
150.
It is showing some mistakes.
Uh,
So let's see
Good.
what are all the mistakes. So see, outside interface is wrong. So it is outside. Okay. Next, what is saying? It is showing crypto ISA KMP policy is not being accepted by the firewall. Okay. So it is because now in the slide also which I had shown actually, might have skipped that. So we have IK1 and IK version 2 actually. Okay, so earlier there was only IK version 1 actually. Now we have IK version 2 also. So IK version 2 IK version, what is it? We can use IK version 1 or IK version 2. So okay, we most of the times nowadays we use IK version 2 actually because it is more secure. Okay, it is more secure and it is more faster. So we use IK version 2 because it is available now. But if we have just for VPN purpose, okay, if there is no compliance, security compliance and everything required, right? We can use IK version 1 also. Okay, so because now we have two versions, okay, we have to mention specifically in the crypto policy. Okay, it depends on the code actually. So now on the ASA firewall we have updated code. In here we will be having some updated code. It is 9.9. So we have to give explicitly. We have to give crypto, right? And we have IK version 1 policy 10. Okay, and then we can give the same thing.
Okay, I see.
Now it will accept because the new code, the older version will not, commands will not, are not accepted. Okay, same thing for what you say. This one also.
Okay.
Version 1. Outside. So once we have defined the policy, we'll attach that policy to the outside interface. Is this part clear?
Yeah, completely understood.
So if you
Yeah.
do a show run crypto, you'll see that the IPsec command has automatically taken it as IKK version 1. Okay, so it has automatically converted, but for the ICMP policy, it was not able to convert. So we had to do it manually. This part clear?
Understood.
Mhm.
Yeah.
Yes.
We'll go to
All right.
4 now, and same thing, whatever we had copied, right? So here. So you can mention it now itself here, right? IKV1 policy 10. Side caps. Crypto. We have done it, right? We can enable logging also on one of the firewalls. Okay. So now we are seeing the login message here. We'll start to do a ping to the remote machine. Then 1.10.
It is not getting there yet.
Now it is working fine. You're able to see, right?
Yeah.
Yes.
VPN is
First
working
one
fine.
always.
Okay, so if you see here, what is, if you're able to see right now, so we, first of all, we stop. If you see here, first it started when once it received the message, right? It received the message on port 500. Okay, once it has received the message, right? It has received the message. What it did, it checked for NAT traversal. Actually, there is nothing, so it will check for the policies. Okay, now once the policy is matched, okay, main mode true. Okay, then it is coming to the next one actually. So if there was, the proposal was not matching, then it would not have formed the VPN at all.
Correct. Yeah. I see.
Okay, so whenever the packet is coming, it is the external IP address is coming from the public IP. Internal IP will be the private IP address. Okay. This part is
Understood. Correct.
Okay.
Okay.
so this is the VPN tunnel. Now, if you want, like, we can just what we can do is come here. Okay, and we can type it as encryption. Okay, now I've changed that encryption. Now, if you see, still it is pinging. Okay, why it is pinging still actually? Any idea? Because the tunnel is not like we have given a timeout, right? We will have to
Yeah,
again
the timer has
negotiate.
expired.
Okay, so if you want, we can type clear crypto T1. Want to clear what is say for IPsec, you can see.
Now it is not getting there. Yeah.
So this is why it is happening actually. It is happening because it is not matching the encryption.
The security parameter encryption. Yeah.
Okay. So if you see here now, now we are not forming the tunnel is not forming. So let's form the tunnel again. Yes. Try to ping again. Okay, now it is again.
I think something's me.
Okay. You're getting me?
Yeah, I'm getting you.
Yes.
Okay. So this is just a basic VPN that we have, okay, between two ASA firewalls. And it again, the steps are already there in the ASA firewall itself, okay. So you can form directly from the ASA firewall. And next one we wanted to do is between ASA firewall and a router.
Okay.
Okay. Same thing we'll try to do between ASA firewall and